Welcome back. This is the second video in a series, a formal introduction to Cimatron Quick Electrode. Today I'd like to discuss designing electrodes with solid functions, electrode templates for design, and 3D trajectory. Let's jump back into the battery core from the first video. I'll start with the extract electrode function again and drop a blank near cavity 1 in the lower left. I'll select some faces in the area I'm interested in and accept them with my middle mouse button. Then I'll fit and center my blank and clean up the selection. This is a workflow that I like to use. Finally, I'll recenter the blank and OK the electrode. Now let's hide the core and focus on the geometry. I'll start by creating the blank using the default settings. Next, I'll select Burn Body. This function will build a solid cube around the faces I've selected and automatically subtract the core faces from it. In simple situations, it will simplify the resulting geometry. Let's select Remove and Extend from the Solid function menu and start to defeature the burn body. First, remove the two boss details, then the step in the pocket. Next, we'll use the Extrude Remove to cut away more geometry in a few operations. If you miss faces as I did, Cimatron is a parametric solid modeler. You can jump back and edit any feature if you don't like its results. Next, create a mirror copy of the geometry using the back face of the object as a reference, using the option to merge and refit the blank to the new geometry. Now we're ready to select a holder and place the electrode user coordinate system. Let's add the other locations. I'll use the option by points and select a single anchor point on the electrode to match to the core. This is a fast way to add locations that don't need to be rotated. Then I'll use assembly copy and add it to the other cavities. Let's skip to collision detection until the end this time. This time I'll select the shutoff face in the same area and OK the electrode. Next, I'll create the blank and extrude the three faces to the top of the blank. Then offset the three sides of the object and copy mirror like the last electrode. Let's refit the blank, add the holder, add the electrode user coordinate system. Now we can add the extra locations for this electrode and copy it to the other cavities. Let's extract another electrode. This one will burn the lower lip next to the last electrode. I'll use the extract electrode and drop a blank in the area. Then I'll select one face to define the areas to be burned, accept and OK the electrode. Starting from the top, I'll create the blank, then the burn body. Then I'll use Extrude Remove and Remove and Extend to defeature the electrode. Now we're ready to select a holder and place the electrode user coordinate system. Next, I'll mirror to the other side of the part and copy to the other cavities. This should give you an idea of how Cimatron can create electrodes using solid functions. Next, let's take a look at electrode design templates. Notice the rib detail at the end of the part. It's new. I'll start with the extract electrode function and select every other rib on the left end of the part. I'll accept and OK the electrode. Then create the blank, burn body, extension, holder, and UCS. Next, I'll extract the ribs I skipped earlier to a new electrode. Let's hide the core block and show the last electrode. Cimatron offers two options to the electrode designer for applying templates. For this electrode, I'll select the function Apply Template by Reference Selection and pick electrode number 7 from the screen. Notice the system was able to replicate the process on electrode 8. Next, I'll activate electrode 7 and I'll save it as a template to my hard drive. This will allow me to use it on any other similar geometry in the future. Let's jump back to the top and extract the two ribs on the right end of the part. This time I'll set the option to apply a template automatically and select the template I just saved from the drop-down menu. Notice the electrode was completed with very little effort. Because the geometry of these three electrodes was simple and similar, the system easily duplicated the desired process. That brings us to our final topic, 3D trajectory. Many times an EDM user may need to actuate an electrode on some path other than straight down. 3D trajectory allows the Cimatron user to assign this new path to the electrode in the design. I'll show you how it works on electrode number 9. It should drop down beside the core and burn in sideways. First I'll select the function 3D trajectory and select the electrode. Then I'll add each step of the trajectory. For this electrode I'll use 2 linear motions. If I needed, I could also choose radial motions around the z-axis. I went ahead and defined the trajectory for the other locations. Let's take a look at a simulation. Notice the motion simulation pulls each electrode along the defined path. Thanks for watching. Join me next time for Introduction to EDM Setup, Electrode Drawings, Assembly Drawings, and the EDM Setup Report.